hardest with embedded stuff. For last 80 years, I'm embedded software engineer, so working mostly with industrial automation equipment, doing software insider. So I'm not a field engineer or automation engineer or process control engineer. I'm doing software for industrial automation things, devices. But I started with Java, so I believe in Java and like it. So I think I'm the only one Java person among C guys. So it's not an easy life. As I said in the morning, IoT is not only about new things. And during my work, I had experience that maybe not field engineers, but the business wants to have data about its processes, about how factory works, and about different stuff which is like named as Industry 4.0. During history, there were several revolutions in the industry. So as you know, the first one was the mechanization, the steam power, the coal. At that time, the process control of stuff was rather mechanical. The second one was the mass production, electricity, and assembly line, like the Ford did in States. The third one is the first appearance of real computation in industry. So the computers, programming logic controllers, and automatization. And well, during this period, of course, there were communication. The devices communicate with each other, but it was mostly for process control, so or for safety, to ensure that the factory, the line is doing what is intended to do, and it is doing it in a safety way. But recently, there is so-called Industry 4.0, so it's a fourth revolution. Many people think that it's like the very important one, where business, the factory owners, want to have as much data as possible from the floors, from the factories, and get knowledge from this data. So process this data, learn about the factory life from this data, and take actions. Not only visualize, have nice charts about the production, but also like take a knowledge from there. Actually, during my work, I was involved in Inverters project, the cooperation between university in Bournemouth in England, chemical factory Evonik in Germany, and us at that time REC, the software solution company, and it was a European Union funded project, and we were creating the soft sensor platform. So the platform for getting the knowledge from data. So creating some predictive analytics stuff to analyze the data. And it was my first contact with real industry in the industry. Industry is very broad. The term is like connects many different domains. So it's chemical plants, oil and gas, food processing, and even like logistic transportation. So maybe not all will agree with that, but I think that also there are a lot of automation, a lot of data in logistics that can improve its in process. And Industry 4.0 actually takes into account a whole chain. So from suppliers through logistic, through the process of those goods, and to the delivery to the customers. So it's not only about how to make things, but the whole chain is taken into account. Yeah, at the beginning, well, the title is, I think it shouldn't be there, because it's not IoT and it's not Industry 4.0. At the beginning, controlling of the process was done manually. So we've got manual valves. So the technician was forced to go to the factory floor and close the valve or open it. And also monitoring of industrial process was very manual. So service people were forced to travel around factory and write down the measurements of some equipment. Actually, this is very old, but I wanted to show here that data and controlling of the process was from the beginning of any industry. Currently, there are a lot of levels that we can think inside the factory, inside the enterprise. It is called like pyramid of automation, and from the bottom to up, it's like from the real world, so the analog world, where we need to measure something and we need to act on something and we need to connect to something. It's called components, so it's sensors, actuators, and hardware which connects or assemble these devices. On the upper level, on the shop floor, the factory shop floor, there are programming logic controllers, process controllers, and PID controllers to take values from the real world, the analog one, convert them to the digital form and act on them. On this level also there's a safety, which is always done in parallel. So we've got two processes. One is two automation infrastructure. One is for process control. So for example, if we mix something, we need to measure how much of one substance and how much of the second substance we are providing to the mixing bowl. And of course, close and open the valve and then start the mixer, control the temperature, pressure, something like that. It is usually done on this level. And in parallel, of course, there is a safety system which monitors the safety aspect of the process. So for example, if the pressure of the tank is too high, way above the normal level, this safety process needs to shut down the process and turn on some safety features, like open some emergency valve or something. And here we also have communication. Right now, communication between PLCs with sensors and actuators is mostly analog, but of course, there are digital communication channels between them. From this level up, we've got SCADA network. It's systems that they are the systems that take all the data from different parts of the factory floor and aggregate them, store them, and visualize them for the operators of the factory. So those data are really rather raw. They are not really processed, and they are used to monitor the process which is done below. Above it's a system that allows the operation of the whole factory to be monitored from one place. So, for example, the efficiency of the process, the quality of the process, and usually those systems are kind of enterprise one, and they take data from the SCADA systems and are and it is usually done in online way to have the current situation of the whole factory. And of course, on the enterprise level, the financial data are there. So the how the whole enterprise, so for example, several factories are doing, what are the delays in the supply chain and like that. Now I'll show you some field devices with Modbus. Here I want to show that, of course, current factories, the new one or upgraded one, have the real sophisticated and new devices which are already connected. So the design of the factory assumes that everything is connected and data are flowing to the ERP systems, to the like a CEO, that he will know that he's earning money. But also there are factories that have processes that are like done 20, 30 years ago, and it is quite expensive or time-consuming to upgrade them into the new infrastructure. And using smart gateways or open source software, I think it is easy to provide a parallel way to access the factory data. One of the basic component of the process control system is PLC. Actually, this is mine, or borrowed one, and I was doing the prototype on that. This device has inputs and outputs, so we can take data from the real world and act on something. So the input-output can be digital, so only on and off, analog one, so we can measure some signals. Usually it is there's a standard for analog inputs. It's 0 to 10 volts or 4 to 20 milliamps. And of course you can have relays inside the PLC or as extension modules. Those systems usually scales quite nicely. Here is an expansion port that you can add I/O extension devices. So it can scale quite nicely. Usually, even the very old one provides some form of communication channel. The most popular among old PLC is RS485, where the Modbus protocol or some form of raw data can be accessed from this PLC. Of course, there is Profibus by Siemens, and Ethernet. It is also popular, especially in the new one. Of course, you need to program it. It is not really hard, but you cannot program it in Java, especially the old ones. You cannot program it in C, but you can program it in ladder language and the functional block language. So you need to have special skills to do it. Some of the PLCs also have local HMI, so some display that you can program it. The other kind of devices which could be used in such use case to monitor existing process is a remote I/O card. Sorry for the bad picture. It allows you to connect sensors and actuators, similar like PLC, but only to measure and act on the data. So you can connect here, for example, some switches, and using the communication channel, usually the Modbus or Ethernet, you can connect it to your monitoring network and see what is happening and get data from that. It doesn't need you don't need to program it, because it's like a ready device. and yeah, it can work, of course, remotely, and it also scales quite nicely. Some of the companies create these remote IOs in a way that you can chain them, and from the communication net channel you see only one device. So it is quite nice. And of course, many others like meters for temperature, level, flow, pressure. They are simple one that gives you only the value. For example, like temperature in an analog form. But they are also more sophisticated, like flow meters that measure the flow of something. But also they can measure the temperature of this liquid or gas, pressure, viscosity, and many other stuff. Those more sophisticated ones usually have some communication form, like a MODBUS or Profibus, and even they can work as process control devices. So, for example, you want to fill some bottles, you can measure the flow, and those flow meters, those sophisticated flow meters, have analog outputs to open and close the valve in a way that you will fill exactly the same amount. There are, of course, inventors to control motors, some HMI panels, gateways. I mean, like a dump gateways that only convert the protocols, and of course some signaling like lamps or something. Okay, so maybe fast about Modbus. Modbus is an application layer messaging protocol. From the developer, it's an application layer, but in fact it's an application and a presentation layer, and it uses the physical layer. It is not specified in the Modbus standard. You can use any of that. So the most important for old devices or old system is the RS485. It's a serial communication, and I will talk about it later. You can of course use Ethernet. There are some extensions like Modbus Plus that you can have several masters. And Modbus is a master-slave protocol. There's only one master on the on this network and several slaves. Using the Ethernet, it is specified with Modbus on TCP, but also you can use like if you don't want to spend a lot of effort, you can use the Modbus variant for serial communication over TCP. It's not according to the standard, but yeah, we did it several times. Of course, you can pass the data over any serial medium. So if it is a USB or some radio link, it is also possible. It was published by Modicon in '79, so it is old like me. Right now it's a Schneider. It's an open structure, and it is freely available. You can go to the website and take the specification. It is widely known and flexible. It is very easy to implement in modern computers or microcontrollers. It is very easy. I think a year ago we did our own implementation of Modbus for some specific hardware. I think in 2 months, one person. So it's not really a lot, and it can work on physical layers. Okay, it's a half duplex protocol on the serial line, so you need to control the data flow. You can do it full duplex using two channels, two serial channels. Really fast. Okay, so we've got a Modbus master and some Modbus slave devices. and the Modbus masters always starts the conversation, so it sends the command to the slave, and the slave is responding. There's also a broadcast message where the slaves do not respond, and everything is specified in the Modbus. Yeah, master is only one, and always interconnection. There could be 247 slaves on the same bus, and the slaves cannot communicate with other slaves or with the master. They cannot initiate the communication. This is the frame. I think, are you interested in details about the Modbus protocol? Because I think I should skip it a little bit, just to say that the protocol frame consists of function code and data, which is like a command and some data for that, and it is wrapped in the address of the device and a CRC code at the end. Yeah, so Modbus specifies several commands and a place that you can implement your own commands. So if your device wants to be advertised as a Modbus device, it needs to support like some of those functions. It is not mandatory to have all the functions implemented, but some of them must be implemented. If you want to reuse Modbus in your own communication inside the device, that it won't be available outside, you even can have your own commands and do not provide this one. So in Modbus, there's a concept of like two data types. One is coils and internal bits. So it's there are commands to read coil and write coil, or to read the discrete input. So it's a bit. There's a meaning only of a true and a false. So it's you can write the single coil and, for example, turn on the relay or close the valve. In this case, difference between single and multiple is that in the single coil you only specify the address of one coil. In the multiple you can have the continuous range of coils, starting from some internal address, ending somewhere. And the other data type is input registers and holding registers. They are 16 bits, and they are for accessing the data which are stored in a PLC, for example, or in some kind of meter. Of course, you've got some diagnostics functions, and a place to implement your own things. For example, if you want to allow to update the firmware of your device, or there is such function to update the firmware, and it is specified in the documentation, you can use your smart gateway to update the firmware of this device, for example. So I skipped that. So the maximum data where you can send using the RS485 is 256 bytes. It is because there is also, of course, the slave address and CRC. On the TCP, it's less. What is it? RS485. It's a specification of differential balanced line over twisted pair cable. So for the electrician or electronics engineer, it's clear, but for the computer science or IT people, maybe not. So normally when you have the serial data, you send bits over one line. So there is a high level and low level, and receive data over the second line. And to decode this data from electrical signals, you need to measure if it is high or low, and then form the frame. In the differential line, you've got two lines, and the driver is responsible to set the voltage between those lines. And it is done on a twister pair, like in Ethernet. And it is very friendly for noisy environments. So especially in factory, when you have a lot of motors, inverters, and a lot of electrical noise, it could disturb the simple serial connection, like RS-232 or UART on TTL level. And it can have a very long range, over 1 kilometer. Of course, the speed decreases, but still it is very useful. So, how I started with Modbus and Kura. It was my idea for Eclipse Open IoT Challenge 2 years ago. I started to experiment with that based on my experience from company. And to start working, I of course choose Raspberry Pi. It's quite cheap, and I created like a prototype with two Raspberry Pis. On one, it was the Modbus Modbus slave implemented using the lib Modbus library, open source Modbus library for C. And on the other Raspberry Pi, it was Eclipse Kura, and all it was connected using the transceivers MAX 485. There were several problems, which I will explain later, hopefully. In order to connect to the RS-485, you need to convert it from your serial port. Usually in computers, you've got the RS-232, but on the small computers, you've got like Raspberry Pi or Arduino, you've got UART with TTL level voltage. So it's either 5 volt or 3.3. So you can use cheap one, I think from China, where you don't have the automatization of data direction. So it is your responsibility. Your software is responsible for controlling the direction of the data over the line. This one is only for prototyping. It is not industrial grade. The other option is to use USB cable. It is very convenient for laptops because you don't have the COM port here, and it has automatic data direction, but it lacks of any protection for your computer. So if you put the high voltage here, probably your USB cable, your USB port will be broken. So it's for prototyping, but it's very nice. And for industry, you need to use some gateway or converter. This is made by Moxa, industrial grade physical layer converter, and you can have a power supply here. It's 24 volts. Additionally, you've got some socket over there, and here you have the ground and two cables connected to the RS-485 channel. It has automatic data direction control, and also it is well guarded against any shortage or high voltage. So there's isolation inside. What is Eclipse Kura? I've got 7 minutes or so. 5. Oh, okay. So Eclipse Kura is framework for IoT gateways. It is written in Java and based on OSGI. So all the nice things from OSGI you have there, like modules, services, event admin, and others. Additionally, it provides you with API for accessing hardware. Right now, it is provided for Raspberry Pi, BeagleBone, and Intel Edison. And Eclipse Kura was donated by Eurotech to Eclipse Foundation, and they have their own product, ESF, I think it is called, which runs on their hardware. So for sure, they provide like commercial support for that with many different hardware APIs. Additionally, in managed network configuration, provide you with the Modbus and CAN libraries, and additionally, very important thing for monitoring, it provides data services and cloud services. So you can connect to the MQTT broker, and from your application in this framework, you can send data to MQTT broker, or on the higher abstraction level, you can use cloud service when you reuse one MQTT connection and send data using this service also to the MQTT broker or some IoT platform. Eurotech provides you with the very nice IoT platform everywhere, I think it is called, where you can manage the Eclipse Kura or their ESF stack from this platform, and of course store data there and provide some analysis.
And a huge chunk of this platform is going to be part of it's actually going to be open sourced. If you look for the Eclipse Kura project proposal, and many bits that are part of the Kura cloud counterpart will be open source as well.
Yeah. So this is the overview of the Eclipse Kura. I will not really talk about that. This was my idea for monitoring of some industrial equipment. So you've got here the PLC, some inverter, and the BeagleBone. It is all connected using MODBUS RTU, using the converter. At that time, I had this cheap one. And on the Raspberry Pi, I've got Kura and my Modbus monitoring app. Additionally, I wanted to incorporate Lesson there. So with some first tries, it was okay, but then I haven't got time. And the Kura and my application was responsible for sending the data to the MQTT broker. This is my my hardware setup for experimentation. So we've got the power supply, the high voltage, the low voltage for the Raspberry Pi, the PLC. This is some diodes, LEDs, Raspberry Pi, and the prototype control panel. I have a slide for setting up the Kura, so if you're interested, I could share with that. It is also available on the Eclipse Kura site. You need to in order to have the Modbus, you need to modify the target platform. So add the Modbus Modbus jar and add it into the target definition. There. Yeah. So installing the Eclipse Kura is quite simple. You just need to download the package from the release site or from the Jenkins on the Hudson instance with the latest development one and have it installed. Then you need to install in the running Eclipse Kura, so the OSGI container. You need to install the Modbus bundle. It is available in the repository. You've got the latest version is from February. And using the the command prompt, you can install it, or using the Kura web interface. How to use it? I'll just be very quick. You can use it using Eclipse PDE. So if you have the workspace and you have the dependencies there, you can write your the simple OSJ bundle and reference the service Modbus device service. And from there, you need to set up the Modbus connection. For Ethernet, it is quite simple. It will be available on this port on 502. And for serial, there are slightly more. The standard serial parameters, and the transmission mode, RTU or ASCII, and the serial mode. It could be RS485 or RS232, but currently Kura do not support the direction control. So it is up to you, up to your application to properly change the direction of the data in the serial line. Then you configure connection and have some functions to simply read data from the Modbus and to write data to the Modbus. So I think that is all. Do you have any questions? Yes.
So do you think Modbus is going to be around for the next decades, or things like OPC, UA, or maybe other protocols are going to take over eventually?
I think it will be for for decades, because it is well established, well known, and as I know from the experience with factory operators, or with even with marketing, or from the companies that make those hardware, the industrial hardware, they don't want to have real revolutions. They want to have some things that are stable and well established. Of course, they will provide you with additional equipment that can be connected to them, for example, Modbus or different low-level protocol, and have those data up to the ERP for CEO. But for example, once I asked if we can incorporate some GSM module into the one of the meters we are developing. If it will be like it will be a successful project. And he said no, because they don't want to have like different kind of communication channels in the factory. They want to have only one reliable, and then somewhere else they want to connect. But if we have small factory, or you have some device that is not connected to any infrastructure, and you want to monitor it, Modbus is the choice, or any other low-level protocol. So thank you. It was my first talk of any conference, so I'm sorry. And please evaluate and give me feedback. I would like to improve myself.